This question is called the amoeba problem. It says there is one amoeba in a pond. After every minute, the amoeba may die, stay the same, split into two, or split into three with equal probability. All its offspring, if it has any, will behave the same and independent of other amoebas. What is the probability the amoeba population will die out? So one amoeba can go begin like a very long journey. Let's say like we have one amoeba, right? This was like the start. They can like double, triple, and then they can all die out. So the chance that this one amoeba eventually dies out, we don't know what that probability is. We can call it the probability of E, right? And so this one amoeba, we said it can go like it can die out, it can stay the same, right? It can die, stay the same. It can split into two, or it can split into three. And the chance that this amoeba, like from inception into the root of it dying, we're not sure what it is, but it's probability of E. And that's what we're trying to find. What is that probability? Like for example, if it stays the same, right? Then what's the chance that this amoeba dies? It's the probability of E, because this amoeba can go on to some journey. It can this amoeba can either die out, it can double, or it can stay the same as well. It can double, or it can triple. So every amoeba can go on some journey which can lead to it dying with probability of E. Or like where it can lead to that root dying, if that makes sense. So yeah, like the chance that this amoeba, all of its offspring also lead to like end up dying as well, is probability of E. And the chance that this amoeba dying on its own immediately is 1/4. But it can like double, and then each of them can die as well. So you have to add that probability onto that as well. So it's like this amoeba can either. So let's break it down. So we're trying to find the probability of E. We're trying to say, okay, now there's one amoeba. Let's start off with here. Let's not complicate the other steps. So we can erase this for now. Well, there's the chance that this amoeba dies out fully, right? The root amoeba fully dies out, and therefore them all dying out is probability of E. And so there's a 1/4 chance. So let's start off with like actually giving them variable names. So this event, say the chance like the amoeba dies out, we can call it F0. The chance that it stays the same, or like the event that it stays the same, we can call it F1. The event that it doubles, we can call it F2. And the event that it triples, we can call it F3. And so we're trying to find, and conditional probability, conditional total probability just says that probability of E is the probability of E given F0 times the probability of F0 plus the probability of E given F1 times the probability of F1 plus the probability of E given F2 times the probability of F2 plus the probability of E given F3 times the probability of F3. So this is total conditional probability, and it says that to get the probability of E, you look at all the ways E can happen. E can happen after F0, it can happen after F1, it can happen after F2, and it can happen after F3. And then you say, what's the probability of E happening given that one scenario? Find that probability, and you multiply it by the probability of that event occurring in the first place. You do that across all possibilities, and you'll get the probability of E by itself. Okay, nice. Now we can break down how to break down each step, kind of like each event one by one. So the probability of E given F0. We start off with one amoeba. If it dies out on the first step, then the probability of all amoebas dying out given F0 is 1. And then it's times the probability of F0, which we said each event has equal probability. What does it say that? Here it is. Of 1/4 4 events, equal probability, 1 out of 4. And then probability of E given F1. So we said the chance that this root amoeba, like this amoeba and all its offspring die, was probability of E. If we stayed the same, nothing changed, then it's only intuitive to say that the probability of this amoeba dying now, that nothing changed, is still a probability of E. So we can say the probability of E given F1 is just the probability of E, because nothing changed at all. We're back to where we started. And then probability of F1 was 1/4. Now, plus the probability of E given F2. So we said that the chance that one amoeba eventually dying out, meaning this amoeba and all its offspring. So what's allowed? Let's say what can happen. So let's take this amoeba for a second. This one will like underline it blue and draw it blue here to see what the journey it can go on. This amoeba can either die immediately, stay the same, double, right, or triple. Let's say it doubles. Okay. Now there's 2 amoebas. If then now each amoeba can have its own like full cycle. If this one dies and then this one dies, this counts as probability of E succeeding. Okay? Because it doesn't have to die on the first step. It doesn't have to die immediately. It can still double and then die. Or it can like double, this one can die, and this one can stay the same and then die. But as long as we lead to the main amoeba dying and or the main amoeba and all of its offspring, all the like children of that one amoeba dying, that's probability of E occurring. So the probability that any amoeba eventually fizzles out is probability of E. By fizzling out, I mean it dying or it and all of its children dying. It's probability of E. And so it also applies to this amoeba as well. So the chance that both of these occurring now that we have 2, and since they're independent of one another, is probability of E times probability of E. Because when independent, the chance of two events happening is event 1 times event 2, and they're the same in this case, so it's probability of E squared. And probability of F2 we know is 1/4 because equal probability. And now plus probability of E given F3, which we discovered how this works earlier. So it's probability of E for this one, probability of E for that one, probability of E for that one dying out fully. And so therefore it's probability of E cubed now, because we have 3 times 1/4 because equal probability again. And so probability of E equals this. So we can do times 4 across, just to get rid of these 1/4. We get probability of E cubed plus probability of E squared plus probability of E plus 1 equals 4 probability of E. We did 4 times this and 4 times all that, and these cancel, right? And then we can move this over. So we have probability of E cubed plus probability of E squared plus probability of E, minus 4 probability of E on both sides, and plus 1, and then we can say equals 0, and we can solve for probability of E. This part doesn't matter, like it's going to take tedious work. The main part is understanding how we got to this equation. In interviews you can kind of stop here pretty much. They're not going to ask you to solve this out, but the answer is, I think, root 2 minus 1. That's the only positive root that is between 0 and 1. And so that's the answer, I believe. If not, like it's going to be like, and it's going to involve these two numbers, root 2 and 1. I just forgot, but I think this is it. And yeah, that's the whole question.